Great night. How are you guys? It's your physical science teacher, Mr. Marshall A.C. Candiado, and you know it's now time for science again. This is our second lesson of the week. Okay, remember, each and every single week we're going to have 2 lessons. Okay, so from the videos that we sent you, you have 2 videos per week, 2 lessons per week. And at the end of the second lesson, you get to write an exercise and sometimes a test. Okay, so now in this second lesson, we are going to be looking at synthesis reactions. Remember that in the last lesson, right, which was the first lesson, we looked at decomposition reactions. Where we say a decomposition reaction is a reaction in which a compound breaks down into simpler compounds or even base elements of itself. And we gave different examples. I'm sure you remember because in that lesson, which examples did we give? You can try and remember which examples did we give. We gave the example of copper carbonate, where I showed you a video where copper carbonate was being heated, and that was an example of thermal decomposition. We said it's also an example of an endothermic reaction. But today we are now looking at synthesis reactions. Okay, so what are our objectives for today's lesson? So if you look at the document, I hope you're holding, as always, the document. Each video is accompanied by a set of notes, right? And in this lesson, it's those notes that I'm going to be explaining to you guys, because I know that you guys sometimes you read and then of course you understand, but you always want yours truly to come in and just add in a bit of salt, a bit of spice, so that it just sinks into your wonderful minds. Okay, so what are today's objectives? So today's objectives, I have written them also on the board, right? Don't mind the handwriting. You know my handwriting. It's a wonderful handwriting because it's coming from a wonderful person, right? So the first objective for this lesson is that by the end of this lesson, you should be able to define the term synthesis. Okay? You should also be able, by the end of this lesson, when we say we have finished this lesson and we've watched the video several times, you should be able to then identify and describe several synthesis reactions, right? There are synthesis reactions that I will give you in this lesson, okay, that I'll explain in this lesson, but then you also have to go and look at other synthesis reactions. So by the end of this lesson, when you have watched it and you've also looked at different sources of information, then you should be able to say, okay, I know 1, 2, 3, 4, 5, 6 different synthesis reactions. Okay, then also by the end of this lesson, you should be able to explain that many useful substances are made from simpler substances. How so? Because if it's a synthesis reaction, you're going to have simpler substances being combined to form more complex substances. The previous lesson was decomposition. You were breaking down complex compounds, forming simpler compounds and even base elements. But now, this is synthesis reactions. So with synthesis reactions, it means obviously you're now effectively doing the opposite of what we were talking about in decomposition reactions. Okay, so let's look at this lesson, right? So I'll effectively be explaining the notes that I've given to you guys. So a synthesis reaction is a reaction in which you take simpler compounds or base elements and they are combined and you join them to form complex compounds. You take simple compounds, simple compounds, and you join them, right? And you form this massive complex compound. As I was saying that, I just remember this thing from Stranger Things. I don't know if you ever watched Stranger Things, when there was this big monster, it would have smaller individuals just coming in and fitting into this big organism, and it would form this gigantic monster. It was a massive monster. But that was also an example of a synthesis reaction, because it was effectively taking different individuals and then joining them together the same way Voltron does, if you know Voltron. Maybe Voltron is from too far back when we were still kids. But if you know Voltron, you would have different individuals, or the Power Rangers, those different guys. They join together, they use their individual powers to form a much, much bigger power, a much, much bigger force, okay? So, synthesis reactions, you have elements combining. You think of any element. You think of maybe hydrogen, okay? You have hydrogen, it combines with oxygen. What do they form? Do you recall? If we take two atoms of hydrogen, join them with one atom of oxygen in what we referred to and what we termed as a covalent reaction, a covalent bond, okay? Covalent bonding, they'll form water, okay? That is a basic example of a synthesis reaction, actually, even though it's a chemical reaction. Right, so the definition of a synthesis reaction, this is a reaction in which simpler substances are joined together to form a much more complex substance, or elements are joined together to form a much more complex compound. That is a synthesis reaction. Okay, so now that we're able to define a synthesis reaction, we should be able now to think to say, so in our everyday lives, there are several synthesis reactions that take place. When I try to think of the simplest one, I was going to start just running off with the different synthesis reactions. But I think I'll just take this chance to say, pause the video, pause it, so that you can think for yourself to say, which synthesis reactions have I observed in my surroundings? Which synthesis reactions have I observed, even if it's at your house, or when you were in the shops, or wherever it is you were? Which synthesis reactions have you observed, or do you think that this might possibly have been a synthesis reaction? So I'll give you 3 minutes. You can pause the video, I'll give you 3 minutes. You can just rummage in your mind, look through your mind. All the answers, that's the beautiful thing. All the answers are there in your mind. So I'm going to give you 3 minutes. You can pause the video now. Okay, so yeah, it's the video that pauses. I don't pause. I just pretend like I pause, but I don't pause. I just continue living my life. When you pause the video, you don't pause me. You pause your video. Right. So I hope you were able to think of different synthesis reactions that you have probably seen in and around your house, whether it's here at school, at Dr. Sidney Memorial College, whether it's at the shops, at Pick and Pay, ShopRite, or at different events. Okay, so I would like to put to you, I think the simplest synthesis reaction, when you take your mahangu, you mix it with water, and you boil it, and you say you have made porridge. That's an organic reaction. That is a chemical reaction that is taking place there. It's a chemical reaction, right? It's a synthesis reaction. You have taken your mahangu, I don't know if it's mahangu powder, I know it is maize meal. In our country we have maize meal. Okay, so if you take maize meal and I mix it with water, and then I get sadza, or I get pap, or I get porridge, right? Then I know that I actually had a synthesis reaction. I think that's the simplest one that I can give to you guys. But then another simpler one, right? Another simplest synthesis reaction is that of photosynthesis. That is a naturally occurring synthesis reaction. So also, grade 9s, as you're reading, as I'm giving these videos, I just give you a basic outline of the concept. I give you a basic outline of the topic. From this information, you should then be able to go and research. Research as much as you possibly can. Go on to Google, right? That's the beautiful thing. We have Google these days. You just Google synthesis reactions. You read more, right? You enrich your mind and you open. And like I've told you, every single time it's written on this document, imagination is everything. Free your imagination. So you have to think to yourself, which synthesis reactions have I seen? The simplest one is there. Photosynthesis is happening all around us. It's happening all around us. So during daytime, we know what photosynthesis is. We know what photosynthesis is. And how does this photosynthesis take place? Photosynthesis. Photosynthesis. Okay, so I will write the word equation just now. Okay, but I would like to emphasize on the importance of this synthesis reaction, because you're going to look at different synthesis reactions. You're going to look at some of the synthesis reactions are natural synthesis reactions, some of them are natural synthesis reactions, while some of them we call them synthetic synthesis reactions. Natural synthesis reactions are those ones which take place naturally in the environment, like photosynthesis. Photosynthesis happens by itself in the trees. You don't even need anyone to come and ask the tree to say, Mr. Tree, today can you please make us maybe 5 cubic decimeters of oxygen, please, Mr. Tree? And then the tree says, no, the tree just does it. It's a natural occurring process. Okay, and this is probably the most important process that's happening on this planet right now. I'm sure we talked about global warming when we were in grade 8, right? And how we can combat all those issues of global warming. How can we remove all this carbon dioxide that is in the atmosphere? We have scientists, we have governments going to different seminars, different organizations. How do we remove all this carbon dioxide that's in the air? Simple. We just plant more trees. Yeah, that's it. That's it. It's a bug. It's a bug. It almost got into my eye, but it didn't. It's still there. It flew away. Cool. Right? So, trees are the solution. You plant more trees, they absorb this carbon dioxide. They absorb this carbon dioxide. Then some people would say, but then trees respire in the evening. It doesn't matter if trees respire in the evening. There is no way that trees can produce as much carbon dioxide as they absorb. It's an equation that is balanced in our favor. It is skewed in our favor. They take out. And trees love this carbon dioxide. Okay? Trees love this carbon dioxide. The same way you love ice cream, the same way you love pizza, it's the same way trees and green plants love carbon dioxide. So we have this problem of global warming, right? But we have a naturally occurring synthesis reaction that solves this whole process or in this whole problem of global warming, and it's called photosynthesis. So what is photosynthesis? I'm sure you know the definition. I'll just say the definition because you're watching a video and you have me at your disposal. So photosynthesis, as we know, is the process by which green plants produce food by using what? Carbon dioxide. And this carbon dioxide, what do they do with this carbon dioxide? They combine with the water. The water from where? The water that is coming from the ground through the roots. And they do this in the presence of sunlight and chlorophyll. That is the simple definition that you have of photosynthesis. And what do they produce? They produce carbohydrates, that's the food that we eat, and they produce the oxygen. All that oxygen in this room. I'm alone in this room. You guys are not here, so I'm alone in this room. So the amount of oxygen, this room is just so fresh. The aircon is on, the room is cool. So the aircon is on, and the room is just so cool, and there's just so much oxygen. Okay, so we have photosynthesis as a base example of a naturally occurring synthesis reaction. And we say for the equation, you will have, I'm going to write the chemical equation because I don't want to write the words, it's too much for me. Okay, so you would have carbon dioxide plus H2O and reacting with the process in the presence of light. And then you also have chlorophyll. Okay, you also have chlorophyll, and what is the product? The product is CH2O. That's a carbohydrate. Right? And then you also have energy. You also have oxygen that is produced. You also have O2 that is produced. You don't have to worry about the chemical equation. What we need to know is that we have carbon dioxide. The carbon dioxide is reacting with the water. The carbon dioxide reacts with the water, and then because they get energy, because this is now photosynthesis, this is a reaction which also takes in energy from the surroundings. It means it is also an endothermic reaction, right? Because remember that reactions which absorb energy, Okay, reactions which absorb energy are called endothermic reactions. They take in energy, they don't give out energy. This is the same with photosynthesis. Okay, so then the product, so we say there's light, which gives it the energy, and then there's chlorophyll, which is able to absorb this light. And it's a key factor for this process. What is the product? The product is a carbohydrate. The carbohydrate, there will be like thousands of those carbohydrate molecules, compounds. Do not worry about it. So carbohydrates and oxygen are being produced. Okay, that is one example of a synthesis reaction, a naturally occurring synthesis reaction, right? Which other synthesis reactions do we have? We have, if you have a situation where you would take iron, you have heated iron and then you pass chlorine over it, right? Now we have a reaction where you can take iron, right? Iron, symbol, Fe, plus chlorine. Symbol. What is the symbol for chlorine? You don't remember the symbol for chlorine? You do remember the symbol for chlorine. The symbol for chlorine, yeah, it's simple, it's Cl, right? And what do they produce? They produce something that is known as, alright, on top here, it's iron 2 chloride. Iron 2 chloride. You remember we talked about balancing equations. If you use the actual equation, because this iron exists as iron 2 plus, and this iron is chlorine minus. And then if we were to join them, we would have FeCl. Remember the 2 goes there, and this one disappears. So this is iron 2 chloride, which means you have 1 iron and you have 2 chlorines. Okay, I'm going to rush. I think I got a bit carried away with that whole photosynthesis thing. I just love the idea of photosynthesis. Okay, so when we have this reaction, it's also another example of a synthesis reaction. Iron plus chlorine forming iron chloride. You can know that you've taken an element plus an element and you have formed a compound. This is an element. This is also an element. We have now joined these two elements and we have formed a compound. Okay? So now let us look at other industrial synthesis reactions. And in our syllabus, the main ones that we have to look at is the production of fertilizers, the production of plastics, right? Pharmaceuticals, even oil, the refining of oil. So you guys can go through, you can look at it. It's there in our preferred textbook, right? In our preferred textbook, you can either be using the platinum, you can be using the living science. Those processes are there. Okay, so if we look at the production of fertilizers, let us think of the production of fertilizers. What happens with the production of fertilizers? What are fertilizers used for? Fertilizers are used by the farmers, our farmers, right, who produce all this wonderful food that we eat, right? Otherwise, if there was no food, then how would Namibia survive? We need food. The whole world needs food. Okay, so when these farmers are planting their crops, they put fertilizers to make the growth of the plants more efficient, so they can grow faster at a faster rate. Right? So you have what you call, for those who do agriculture, you know that you have what you call organic fertilizers. You have what you call organic fertilizers, but then you also, some things like manure, you just go into the crow, you take the cow dung, you spread it out in the field. That is a fertilizer as well. That manure is actually a fertilizer, and it's organic, it's natural. But we also have what we call synthetic fertilizers. Synthetic fertilizers are based on the compound ammonia. Synthetic fertilizers are based on the compound ammonia. And I know grade 9s, when we were in grade 8, right, we talked so much. You remember we talked so much about the compound ammonia. We drew the Bohr diagram for ammonia, so you guys know ammonia by heart, because we spent so much time talking about ammonia, talking about CH4, methane, right? So that ammonia, which is the formula, do you remember the formula? Grade 9s, remember, we are now going towards senior secondary. So we must know, when I say a name of a compound like ammonia, you must know the the symbol, right? The formula for that. So if it is ammonia, allow me to use the space at the top here. It has this formula, NH3. This is the base compound for most of the synthetic fertilizers, right? This is the base compound for most of the synthetic fertilizers that are used in the agricultural sector. Okay, so what happens? What do they do? How do you produce this ammonia? It's produced in a process that is called the Haber process, right? Haber process. It was discovered by, basically formulated by a German scientist known as Fritz Haber. He's the one who formulated that whole process, where you would take nitrogen and you would react it with hydrogen molecules at a high pressure and high temperature, and you combine them and you form ammonia. Okay, then this ammonia is then used to produce other synthetic fertilizers. Fertilizers where you can then, this is where now the synthetic part and the synthesis reaction comes in, right? Pay attention. Pay close attention. So now you take this ammonia, right? You take this ammonia, and this ammonia is going to be rubbed. I'm going to rub the board, not the ammonia. I'm going to rub the board, not the ammonia. So the ammonia, right, is going to be mixed. It's going to be mixed with an acid, such as sulfuric acid. And what do they form? Let me write the equation for you here. Right, let me write the equation. I'm going to write the word equation. I've also put the chemical equation for you in the board. Let me just do this one. So you have ammonia, NH3 plus H2SO4. This is sulfuric acid. H2SO4 is sulfuric acid. What do they produce? They produce something we call ammonium sulfate. Ammonium sulfate. This is NH4SO4. This ammonium sulfate, right? This ammonium sulfate is the fertilizer that you then get to use. It is a combination of ammonia plus sulfuric acid. Okay? This equation will need to say plus hydrogen, or this will be H plus for you to balance. You can balance it in your own time. Right? So what we have is ammonia being reacted with sulfuric acid. This is now again another synthesis reaction, because you are taking this compound and you are joining it with this compound. Observe, this is a compound. This is also a compound. And they join to form a more complex compound. A more complex compound. So you have a compound in ammonia. Ammonia is a compound. Sulfuric acid is also a compound. Then when you react them together in this synthesis reaction, you form a more complex compound known as ammonium sulfate, which is a synthetic fertilizer, right? Also in synthesis reactions, they are also used in medicine, in pharmaceuticals, right? Pharmaceutical industry, production of drugs. So they can be used, and they were actually used if we had this pandemic, HIV and AIDS. So the drugs that were used to actually combat HIV, known as ARVs, antiretroviral drugs, those ones, they're actually a combination of different drugs, right? When you observe that, okay, this drug is able to combat this particular problem with the immune system, then this drug actually gives the patient more energy. So if we were to combine these two drugs, wouldn't they be able to now give the patient more energy and fix their immune system? You see? Then you combine the two, right? So you, a scientist, you will have several chances when you grow up, right, to do all of this. Okay, so you also have people having synthesis reactions also with recreational drugs, but I'm not going to explain anything on recreational drugs. Nah, I'm not going to do that, right? So that's another way in which synthesis reactions take place. But those are what? Synthetic synthesis reactions. They are not natural. Okay, so the other one also, you would look at the production of plastics, where we have what we call polymerization reactions, where you take an ethene molecule and you combine it with another ethene monomer, and you have thousands and thousands of these ethene monomers, and they have a polymerization reaction, and you form polyethylene, the plastic bags that we used. Not that we used, but that we use, because we're still using them. Okay, right. So those are the synthetic reactions, right? Natural synthetic reactions, natural synthesis reactions, natural synthesis reactions, natural synthesis reactions. Forgive me for that one, right? Then synthetic synthesis reactions, which are basically, we have those which take place in the environment and those which are man-made. Those which are man-made. So at the end of this document, you guys will see that I have put an exercise there. I've put an exercise you guys should but you should answer those questions, because I'll be waiting for your answers on my email. You email me the responses for those questions. So what have we done today? Now at the end of this lesson, I'm hoping that you can then have the chance to obviously watch the video again and again and again and again, okay? And then you'll be able to tell that now you can define the term synthesis, right? You are now hopefully able to identify several synthesis reactions. I encourage you, grade 9s, please go and watch different videos on synthesis reactions. Google, right? Research. You always say, we want to research. Whoa! Just like that, COVID-19 comes in. It's giving you the chance. Research. Right? You have the internet at your disposal. Ladies and gentlemen, thank you very much. This is your teacher, Marshall A.C. Candiado. I will meet you guys next week. Thank you.